Everybody tells you to fill a concrete crack with caulk or mortar and call it done. I did that for probably 15 years before I figured out why it never actually worked long term. You caulk the crack, it looks great for a season, maybe two, then winter hits, the ground shifts, and that crack opens right back up, sometimes wider than before. I've recalked the same driveway crack 3 times for one customer before I stopped and asked myself why I was doing the same failed job over and over. Then I started using expanding polyurethane foam instead. Not the cheap stuff from the hardware store shelf, a specific closed-cell foam made for concrete work. I ran it on a basement slab that had been leaking for 6 years. 6 years, 3 contractors, 2 sump pumps. Foam went in, and that crack has been bone dry for over 2 years now, through 2 full spring thaws. That's not luck, that's the material doing something rigid patches can't do. Here's the thing nobody explains. Concrete never stops moving. It expands, it contracts, it settles a little more every single year. Anything rigid you put into a moving crack is fighting a battle it's going to lose. Foam doesn't fight the movement, it goes with it. And once you understand that one idea, you'll never look at a tube of concrete caulk the same way again. Problem. Walk around any house built before 2010 and I'll show you at least one hairline crack in the foundation, the garage floor, or the driveway. Most homeowners walk past it every day and never think twice. It's thin, it's not leaking, it looks cosmetic. That's exactly the problem. By the time you can see water coming through, that crack has been moving water for months, sometimes years, underneath the surface where you can't see it. I've pulled up basement carpet that looked fine on top and found the subfloor black with mold, all because of a crack the size of a pencil lead that nobody bothered with. Water doesn't need a big opening, it needs time and a path. A crack a millimeter wide, given one rainy season, will move more water than you'd think possible because water finds the path and just keeps working it wider. The reason people miss it is simple. Concrete cracks usually show up somewhere unglamorous, behind a water heater, under a deck, along a garage wall stacked with storage bins. Nobody's inspecting those spots. And in dry weather, the crack looks harmless. It's only after a hard rain or when the snow melts fast in March that you get the telltale dark stain or the musty smell creeping up from the basement. By then, the fix isn't cosmetic anymore. You're dealing with efflorescence, maybe some mold, and a crack that's had months to widen under hydrostatic pressure. Why it happens? Concrete cracks for one basic reason. It's rigid, but the ground underneath it isn't. Soil expands when it's wet, contracts when it's dry, and freezes and heaves in winter if you're anywhere that gets real cold. Concrete has almost zero flexibility, so when the ground under a slab or foundation moves even a quarter inch, the concrete doesn't bend, it splits. I've dug out enough foundations to see this happen in real time. You've got clay-heavy soil that swells up like a sponge every spring, then dries out and shrinks every August. That cycle, year after year, is basically the ground breathing under your slab. Concrete just can't keep up with that kind of movement, so eventually it gives at its weakest point, usually a control joint that wasn't cut deep enough or a spot where the original pour had too much water in the mix, which weakens the whole matrix as it cures. That last part is something a lot of people don't know. Concrete that's been overwatered during the pour, and a lot of contractors do this because wet concrete is easier to work with, ends up with a weaker internal structure once it cures. It looks the same on the surface, but that slab is basically pre-loaded to crack the first time the soil underneath it shifts. I can usually tell within the first year of a house being built whether the crew rushed the pour, just by watching where the first cracks show up. Then you've got the water side of the equation. Once a crack exists, water finds it, and water under pressure, what we call hydrostatic pressure, basically the weight of saturated ground pushing against your foundation wall, will drive itself through any gap it can. That's why a crack that seemed dry in July can be actively leaking by November after a wet fall. The crack didn't get worse, the pressure behind it changed. Mistakes. Mistake 1, using regular silicone caulk. This is the most common thing I see, and it's the first thing most homeowners reach for because it's cheap and sitting on every hardware store shelf. Silicone caulk isn't built to bond to concrete the way people think it is. It sits on the surface instead of gripping into the pore structure of the material. Give it one freeze-thaw cycle and it peels right off the edges, sometimes in one piece, like a bandage. I've pulled strips of old caulk off cracks that looked untouched for years. The caulk was just sitting there doing nothing while water traveled underneath it the whole time. Mistake 2, patching with mortar or quick-set cement. This one actually makes sense on paper, which is why so many people do it. Same material, right? Should bond perfectly. Except mortar is rigid, just like the surrounding slab, and it cures without any flex in it at all. So you've patched a crack that's moving with another rigid material, and it cracks again. Usually right along the seam where old concrete meets new patch, because that seam is the weakest bond line in the whole repair. I've seen mortar patches fail in under a year on cracks that see real seasonal movement. It's not a bad material, it's just the wrong material for a crack that's still active. Mistake 3, ignoring it because it's not leaking yet. This isn't a technique, but it might be the most expensive mistake on the list. People wait for visible water before they act, and by then, you're not dealing with a simple crack anymore. You're dealing with crack, plus water damage, plus possibly mold, plus a compromised area of concrete that's been saturated and refrozen multiple times.
Concrete that's gone through repeated freeze-thaw cycles while wet starts to spall, which means the surface starts flaking and breaking apart. At that point, you're not filling a crack, you're rebuilding a section of slab. I'd rather deal with 10 hairline cracks today than one spalled, water-damaged mess in 3 years. But there's one step people always skip when they finally do try to fix it right, and it's the one step that determines whether the whole repair holds. I'll get to that in a second. Solution. Here's the method I actually use on my own jobs on cracks that need to stay dry for good, not just look patched for the next inspection. Stage 1. Figure out what kind of crack you're dealing with. Before anything goes in that crack, you need to know if it's still active or if it's stable. Active means it's still moving with the seasons. Stable means it opened once years ago and hasn't changed since. You test this with something as simple as a strip of masking tape laid across the crack, dated with a marker, checked in 30 days. If the tape's still intact, you've got a stable crack. If it's torn or the gap's changed, it's active, and that changes what you use to fill it. This step gets skipped constantly because people just want the crack filled today. Skip it, and you might use the wrong product entirely. Stage 2, clean the crack properly. This sounds obvious, but most people do it wrong. You're not just brushing off surface dust. You need to open the crack slightly with a diamond blade or a crack chaser bit. Just a light pass, maybe a 1/4 inch wide and a 1/4 inch deep, to remove the weak, crumbly edges of concrete and expose solid material underneath. Then vacuum it out completely, and I mean completely, because any dust left in there is going to block the foam from bonding to the actual concrete surface. I use a wet-dry shop vac with a narrow crevice attachment for this, sometimes going over the same section 3 or 4 times. Stage 3, pick the right foam. This is where people get it wrong even when they've done everything else right. You want a 2-component closed-cell polyurethane injection foam, not the single-component expanding foam from the insulation aisle. That stuff is open cell, it absorbs water instead of repelling it, and it'll actually make a leak worse over time because it holds moisture right against the crack. The injection-grade closed-cell foam is a completely different product. It's hydrophobic, meaning it repels water instead of soaking it up, and it expands into the crack under pressure, filling every void, not just the surface gap you can see. Stage 4, the injection process itself. This is where technique matters more than the product. You drill injection ports along the crack, typically every 8 to 12 inches, angled at roughly 45 degrees so they intersect the crack partway through the wall or slab thickness, not just at the surface. Then you seal the surface of the crack between the ports with a fast-set epoxy paste. This creates a dam so the foam doesn't just squeeze back out the front while you're injecting it. Once that paste sets, usually within 30 to 60 minutes depending on temperature, you inject the foam starting from the lowest port and working up, letting each port push material into the next one before you cap it and move on. This bottom-up order matters. Skip it and you'll leave voids lower down where water pressure is actually highest.
Pro tip here, and this is something that took me years of trial and error to land on. Inject slow, not fast. Everybody wants to blast the foam in under high pressure to get the job done quicker, but foam injected too fast doesn't have time to find every micro void in the crack. It just plugs the main channel and leaves pockets behind it unfilled. I run my injection at roughly half the pressure most guides recommend, and I go port by port instead of trying to do the whole crack in one continuous pass. Takes me maybe 20 extra minutes on an average basement crack, but I've never had a callback on a job done that way. Stage 5, the step everyone skips. After the foam cures, usually a few hours for initial set, but I give it a full 24 hours before I call a job finished, you need to test it under real pressure, not just eyeball it. I run a hose against the exterior side of the wall, or flood the area near the crack for a solid 20 minutes, then go check the interior side. This is the step almost every DIY guide leaves out because it takes patience, and most people just want to be done. But a crack that looks sealed and a crack that's actually sealed under pressure are two different things, and the only way to know which one you've got is to force water at it before you grind off the excess foam and finish the surface. Stage 6, finishing. Once you've confirmed it's holding, you shave the injection ports flush with a chisel or grinder, and if it's a visible area, you can skim a thin layer of hydraulic cement or patching compound over the top for a clean cosmetic finish. The foam itself is doing all the structural work at that point. The surface finish is just for appearance. One more thing worth saying, foam injection isn't the right call for every single crack. If you've got a crack wider than about 3/8 of an inch, or if there's visible displacement, meaning one side of the crack is higher than the other, that's not a simple crack anymore. That's a sign of structural settling, and no amount of foam is going to fix a foundation that's actually moving. That's a job for a structural engineer, not a weekend project. I've had customers try to foam fill a crack that was really a symptom of a sinking corner of their house, and it bought them maybe 8 months before it opened right back up, worse than before. That's the method, start to finish. The same one I've used on jobs where the previous fix failed 2 or 3 times before I ever showed up. It's not complicated. It just takes patience, the right material, and skipping the shortcuts everyone else takes. If you've got a crack somewhere in your place you've been putting off dealing with, tell me about it in the comments. Where it is, how long it's been there, whether it's leaking yet. I read through these and I'll answer what I can. And if you're dealing with water getting into your basement from somewhere other than a crack, through the floor wall joint or seeping up from underneath, I've got a full video on that exact problem and why it's a completely different fix than what we covered here. Worth a watch if that's your situation. Subscribe if you want more of this. Real methods tested on real jobs, not just internet advice repeated back to you.